Hello, everyone. Welcome back to the FY22 CINR webinars. And we're going to start this next session with CT-2 and Jason Marcinkoski. Go ahead, Jason.
Thank you, Julie. My name is Jason Marcinkoski, and I'm the Integrated Energy Systems Team Lead for the Office of Nuclear Energy. Shannon Bragg-Sitton is the National Technical Director of the program out at Idaho National Laboratories. So we are co-leading this topic. So first of all, there's just to show you how to enter questions, there's a box on the bottom of the panel for questions. If you have anything that we don't get to, we will follow up with through posts on www.neup.gov. So here's the, so I wanted to give you an overview of the program first. So please do not confuse this with the actual topic. They are quite different in some ways. So I'll start here with an overview of the main concept behind the Integrated Energy Systems program. So our goals are flexible electricity dispatch for grid balance and plant economics. So if you look at the upper right-hand corner, we show an output to the electric grid here. And secondly, alternative products to expand nuclear-enabled decarbonization and provide additional revenue to plants. So the second and third arrows sort of represent the both the chemical and industrial heat applications for nuclear energy. So to provide these goals, we're really looking at thermal energy storage and heat engines and how they can provide for flexible generation on the grid. And then we have in the box, we've got an industrial chemical plant, very generic here, that can represent many of the processes to produce chemical products, such as the transportation fuels, hydrogen for steel, for instance, fertilizer, polymers, chemicals, or just hydrogen. We call out hydrogen separately because that has been a very important thrust for us in our program. And we show the carbon sources that could be used as feedstocks to the chemical plants, because we see carbon as a basic building block to many products. And there's a lot of opportunities for carbon sequestration here as well. So we show that, although there could be other feedstocks that go into this plant here. Now in LWRS program, we focus on light water reactors. In the current fleet, in integrated energy systems, we tend to focus on advanced reactors. However, in this topic, we're looking at decay heat. So this is really more of an innovative energy systems or innovative energy concepts kind of topic, where we're looking at more of a an application on the edge of our scope. So here we're replacing the reactor with a decay heat source, and that's what this topic emphasizes. So we're looking at both spent fuel as a heat source, or as one of the topic areas, to produce a tailored isotope to provide the heating characteristics needed for small scale or portable systems for specialized applications. In this topic, we are not looking for isotopes for medical or scientific purposes. It's really to drive an energy application. So one of the areas is focusing on the source of heat with the application in mind. The other side of it is focusing on the application side with the heat characteristics in mind. So on the energy user, the application side, we're looking at the process and system design. So we want to use the decay heat from used or tailored isotopes, used fuel or tailored isotopes, and look at the use of radiation to assist in processes. That's not exactly shown here, but we are accepting applications to use the radiation for applications as well, energy applications, potentially like radiation-assisted electrolysis is a concept we've thought about, for example. So we're really looking at appropriate applications for the decay heat. You know, we're anticipating that it's going to be a smaller scale than the heat you would normally get from reactors, but it's important to consider the scale of the heat source. However you decide to utilize the spent fuel or the size of your isotope source, and also consider the life of the heat source. You know, how does that play into the overall concept? How often does it need to be replaced, or is it good for the lifetime of the application? And then, you know, we don't want very niche markets. We need something that has an impact on the national scale, a significant market, something that impacts our energy resources or the waste profile, the emissions of our energy system. And then, of course, we need to consider safety and environmental aspects of the application. So looking back at the diagram, you know, I want to point out that this is kind of a very generic system that includes a lot of, tried to be in the abstract to include all the components that are possible, but not all these components are required. You know, a heat source might be used more directly in an application, for instance. You know, you can skip all this componentry for the most part and just use decay heat for an application, for instance. Or you might just have a chemical process that uses the decay heat. Or it could be an electrical application or combination of them. And then, of course, you know, including some buffering for thermal or electrical outputs might be necessary. So these are kind of optional, which ones you choose to use in your application. So whatever makes sense to the applications you come up with. So we're looking at the plant process interface design, you know, including advanced heat exchangers, or just whatever heat exchangers are required, design of intermediate loops, the balance of plant operation, control systems, utilization of rejected waste heat, for instance, for these coupled energy processes. So thank you very much. Open it up to questions.
So far, we don't have any questions. If any of our attendees have a question, please go ahead and type it into the question box, into the GoToWebinar application, and we'll be glad to answer those while we're here. Okay, here's our first question. If the focus was on biofuel manufacture, would that be an acceptable topic for an application?
I would say it's very possible that the key would be matching the application to the heat source. So there'd still be additional requirements, but certainly a possibility.
Okay, next question. Is the development of new thermal storage batteries using novel isotopes an appropriate topic for an application?
That's sort of a blend of that's a tough one. So, you know, we're looking, the initial concept is really a separation of the two, but I think those two elements could be integrated. But this topic does really focus on the application as well. So I think you could have an emphasis in those areas, but to make sure that the final application of the heat is addressed in terms of appropriate sizing and for the specific application.
And this is Shannon Bragg-Sitton, the National Technical Director for this program and the technical point of contact for this. I would agree that I think that could be an applicable area. I would encourage that if someone is looking to a novel thermal storage concept, make sure that the proposal includes the integration approach. So not just the storage media and the storage technology, but how are you actually going to integrate that with the nuclear system? And I think that will be extremely valuable to better understanding the role of that potential concept. So on all of these, please make sure to include how that interface is accomplished, not just the application.
Great, thank you, Jason and Shannon. Next question. What lifetime are you interested in for isotopic energy sources?
So we're looking to the applicants to link the lifetime to an application. So you would start with application and develop requirements for the isotopes that would be suitable to those applications. So it's really on the applicant to develop those requirements.
Okay, next question. Should the technology investigated reach the power grid?
It's not required by any means, but if you have an idea that is suitable for the power grid, it's optional.
The different integration systems strongly, it says the different integration systems strongly linked and depended on the strength nuclear source. Can you more elaborate on this topic?
I'm not sure I
would-
really understand the question. Sorry, Jason, go ahead.
I was going to say I agree. There's not much more elaboration than yes, they do depend on each other. So they're interdependent, and the strength of the heat source has to be considered with the application simultaneously. So agreed, and that's something we're looking for the applicant to provide, that that matching of the strength of the decay heat source and the application.
And just to add to that, a lot of the work that we do in the program looks at utilization of high temperature, high quality heat from a reactor. What we don't have so much focus on is utilization of these other heat sources, whether that be decay heat from used fuel, waste heat from power conversion processes. And matching to those sources is critical to this system, and as well as with the radiation assisted processes. What is the application? Can it be matched to one of these sources that we typically just throw away, that we don't utilize? That's an area to enhance efficiency as to how these systems operate overall. So we don't want to predetermine what fits in. You tell us what can be matched so that we don't throw this away or treat it as a waste product, but actually utilize it to drive other applications that have value.
Okay, next question. Is the concept using spent fuel dry storage cask possible?
I'll go ahead and jump in there, not hearing Jason. I would say yes. How would you accomplish that with those types of systems? We easily can envision potential utilization of a spent fuel source while it still sits in a pool and it's decaying. Once it's in a dry storage cask, it may be a little bit more challenging or a little bit of a different approach. But I know I would be interested in understanding if there is a potential opportunity there. Right now, again, we look at that as almost a liability, a waste to be managed and dealt with. If we can turn that liability into an asset, that is of interest.
Okay,
Yeah.
next question. Oh, I'm sorry. Go ahead, Jason.
Yeah, I agree with Shannon. I was just kind of in the back of my mind thinking about, some of the the issues involved, the regulatory issues. So it may be good to touch on those aspects, and how the current processes need to be adapted.
Okay, next question. Is the combination of using renewable and fossil energy with nuclear of interest in the call?
I think that this really, it could, but I don't think it's necessary. It is kind of a very popular approach to integrate. This is not necessarily a grid application. It could be a microgrid application, I suppose, or provide some sort of kind of buffering for power. But it's not really the emphasis of this topic, but it could be incorporated.
Okay, thank you. Next, is there a desirable modeling and simulation framework to be used for analysis, or can an in-house framework be used for analysis?
Yeah, I would say that's up to the applicant.
Let me add to that a little bit. And if there's something that exists that can be utilized to assess some of these opportunities, that's something that can be utilized is great. If the applicant is looking to develop a new suite of analysis codes, that may not be the best approach. I strongly encourage any applicant to review the simulation tool set that has been developed by the Integrated Energy Systems Program. What is used to assess these different systems, it would be very beneficial to leverage the capability existing and to ensure that anything new, such as a model or an analysis approach that is developed under a project, that be able to be integrated with this broader integrated energy systems analysis suite. So we've recently updated the analysis toolset descriptions on the ies.inl.gov website. I encourage you to take a look at that and to understand those. You can reach out to the developers of those tools. Those tool sets are available as open source. So that is something that's available to the applicants. We don't want to reproduce something that's already existing or produce tools that cannot later integrate with a broader set of tools that we've developed.
Yeah, I second what Shannon said. I will just clarify that it's not a hard requirement. But we do want to ensure that, if you put the best application forward, you obviously don't want to reproduce tools that already exist if they're available to you.
Okay, thank you. For radiation assisted topics, is it necessary to have an experimental component in the project?
We're not requiring an experimental component. I think it could make for a stronger proposal.
Okay, next question. Is there a threshold power level for the decay heat below which you are not interested in?
So this is a tough one because I think we haven't done a whole lot of preliminary work to at this point to assess the range of possibilities. I would point back to impact on national scale, though. We are aiming to have a national scale impact. So if it's not a large scale, then it has to have a significant market to do that. So it's definitely thought to have as much utilization as possible of energy. It's definitely an advantage in terms of potential applications.
Just a quick note to add to that. You absolutely don't want to set a minimum threshold or anything. I would say it's more about the cost to implement and the potential benefit if successful. If it is very limited in its benefits and it doesn't outweigh the costs, then it's not going to be something of interest. And so any proposal should look to that potential impact in the future, knowing that this might be back of the envelope initially because you haven't done the work in the study, but we need to understand, does it warrant the investment in this technology because it may be at a very low threshold or something to that effect, but overall it could be implemented everywhere and therefore have a very large benefit. So think about cost benefit analysis and preliminary looks at that in your proposals.
I would just ballpark say that we're probably looking at things that batteries can't already do, for portable applications. You would probably want to compare your solution to batteries, I think, to make sure that there's a benefit above using battery technology.
Okay, next question. Can you talk about the production of tailored isotopes again? I am assuming this is production of isotopes via irradiation/activation, which can serve purposes in energy systems and not medicine. Is that correct?
That's correct.
Okay, thank you. Next question. Is a focus on the electrical interface between storage, generator, chemical conversion, and hydrogen generation an appropriate topic for a proposal?
I think that's part of the solution. So really, it's a focal area on the energy user. If you're doing that, then you really need to consider a reference point for either a tailored isotope and the heat characteristics from that, or the heat characteristics from spent fuel, and make sure that the consideration of the decay heat is taken into account in the system. It's really looking at decay heat all the way to the application, where they may be a little bit more focused on the application on one end of the spectrum, or more focused on the decay heat source on the other end of the spectrum. But the project needs to address the system.
Okay, thank you. Next question. What is the motivation of using decay heat in IES? Are there any similar systems existing or pursued in LWR domain at this moment?
I'll jump in. Oh, go ahead, Jason.
Oh, yeah, I think it's really just utilization of looking at something that's right now not used widely as another resource. I'm not certain of all the applications that might exist out there. I have some ideas, but I'm not up to speed on all the applications that exist, so I hesitate to speak about that.
I'll just say the motivation really is to use all the resources that we have. In that, when we look at our traditional systems for nuclear, we undergo fission and we use the heat from that process to make electricity, and we throw a lot of energy away. Used fuel is a liability, not an asset. How do we turn that equation around? How do we make radiation an asset to drive radiation-driven processes or radiation-catalyzed processes? How do we use waste heat? How do we use decay heat? Is there an opportunity to turn those liabilities into assets so that we can continue to utilize the energy from our nuclear system throughout its life cycle.
Okay, thank you. Next question. Will preference be given to utilizing an advanced reactor concept that is farther along in commercialization, such as SFRs and HTGRs, as opposed to MSRs?
So there's no direct use of a reactor in this project, just to clarify, in case that was missed. This is looking at the decay heat source. So spent fuel or a tailored isotope for the heat source. I think there is a preference in using something that is in existence today or could be produced in the nearer term. So if there's a lot of uncertainty into the availability of the heat source, it's not as viable as a solution down the road. So there would be some preference given to something that has a more definite availability.
Okay, thank you. One more question, and then we'll probably end this session and get ready for the next. Last question. Who would own the decay heat source, such as the used fuel?
I think that's an innovation that we would like to see in the work or the application.
Okay, thank you, everybody. Again, if you have questions that come up, you can later on, you can always email neup@inl.gov.